Our next speaker is Paulo Pagliari. He is an associate professor at the University of Minnesota Southwest Research and Outreach Center in Lamberton, a far cry from where Lindsay came from weather-wise this morning. Paulo's research focuses on better understanding of the relationship between soil fertility status and biological processes and how they interact with both conventional and organic cropping systems.
All right, thank you. Okay, yeah, so today we'll be talking a little bit about the fundamental concepts of bioinoculants and biostimulants. There's not going to be a lot of data talked here because Fabian wanted me to do two different talks. One mostly talking about the base concepts and how these products work to try to give you some idea of how do they work? Are they going to be effective in my field? Do I have the conditions necessary for those things to work? Or is this mainly going to be something that I'll be wasting money on and not getting any return? So I think if you have a little bit of that background information, that hopefully will help you understand whether or not some of those products are going to be useful or not to you and how to best to use them. Is not just because there's a graph that says might be able to get 20 bushels an acre when you apply the product, that you're going to get that 20 bushels an acre. So there's a lot that goes into it. Can everybody hear me okay? Is this working fine? Okay. So today we're going to talk a little bit about the definitions, and then we're going to go over where biostimulants are being mostly used. Then we're going to break it down into the two main categories, the biological, that are your fulvic and humic acids, the amino acids, those kinds of compounds, and then the microbial, that are actually microorganisms that are being used to help with certain mechanisms that you want the plant to have help with, usually coping with stress or nutrient depletion, limitation. And then we're going to quickly talk a little bit about how to best use them in cases where they would be effective. There's two definitions out there that we see, one in a scientific definition and one in the European Industry Council, but they're kind of similar. The scientific definition says that a biostimulant is any substance or microorganisms applied to plants with the aim to enhance nutrition efficiency, abiotic stress tolerance, and or crop quality traits, regardless of its nutrient content. And then for the European one, it says that plant biostimulants contain substances and or microorganisms whose function when applied to plants or the rhizosphere is to stimulate natural processes to enhance benefit nutrient uptake, nutrient efficiency, tolerance to abiotic stress, and crop quality, independent of its nutrient content. So those products are not a source of fertility or nutrient. That's not what the plant is getting from them. Usually the plant is going to have some function that is going to be improved. For example, here in this graph, in this picture, we have a little seedling that is growing on a medium without this bacteria. And then on the side, we can see that the bacteria was present, and you can see that the root development is much stronger when you have the bacteria applied. So we're using those agents as a way to improve the crop development, which not necessarily translate back to yield all the time. Those products have been used for a long time in Europe, South America, and the Middle East. Europe today leads the global share with about 40% of the products being used and the market share being in European countries. They have been mostly used and successful in vegetable production, but a lot of other farmers with grain crops also have been testing with some of those products, particularly the biological ones, the microbial inoculants. And then especially the microbial ones are becoming very popular in the United States, especially over the last 10 to 15 years. There's a lot of more development and a lot of products that are hitting the market. So it's becoming a big deal. And this table here is just to break it down. So like the ones that are acid-based, like your humic and fulvic and the amino acids, they cover almost 50% of the market share in terms of product being commercialized. And then the seaweed extracts, they are about 25 to 40% of the market is due to those products. The microbial, or the bacteria, the fungi, between 13 to 20%, and this is the one that is growing the most fast right now because of all the acres that has potential for the use with the grain crops, especially with the nitrogen fixation. And then other products like some chitosan and ascorbic acid and some other salicylic acid, some other products are starting to get more of attention, but it's still very early development. So let's talk a little bit about the mechanisms of action for those substances. That includes the humic acids and the amino acids and all those extracts that are out there. So humic substances, they are naturally present in soils because they are a component of soil organic matter. So when you have plant that dies and start to decompose, or animals or microbial communities in the soil that they die, they start to break down. Then that breakdown will become the organic matter, and that's going to have the fulvic acid, the humic acid. So it's naturally present in soils. There's also natural deposits for those substances, which are the ones that are used for the production of the products that you see in the market. For example, they can get geological deposits and they go through extraction processes, and then that creates your humic acid and then the fulvic acid. And the main difference of these two is the size of those molecules. The humic acid is a very large molecule. It has some charges with those carboxylic groups, but on a charge per area, there's less charge per area on a humic acid than there is in a fulvic acid. The fulvic acid is a much smaller compound molecule, but has a much higher number of carboxylic acids per unit area. So it becomes a much more charge dense molecule, which is gonna, later on, we will see why it's used the way it is. The way the humic acids have been used, they can help improve soil structure. They are natural chelators that can bind clay particles together to help create those good aggregates. For example, here we have a mix of clay particles, plant debris, and microorganisms that are all being held together by those small humic acids molecule that kind of bind it all together, works like a glue, and create those aggregates. Doing that, so just by the process of enhancing aggregation, it will increase water holding capacity of a soil, and because it has those charges, those functional groups, it will also help improve the cation exchange capacity of soils. But as you can see, this is a product that would be very effective if your soil is very poor in organic matter. Soils that has less than 1% organic matter would be the type of soil that would potentially benefit from application of this type of products. Because a soil like Minnesota soils that are 3.5, 4% organic matter and higher, adding this product, it would just be a drop of water in a bucket. It wouldn't really make much difference. But when they are needed and when they are applied, they are very effective at promoting lateral root formation, increasing root hair density. And so it really improves the potential for the plant to explore the soil in all directions. And by doing that, it can help increase nutrient removal from the soil, nutrient uptake. It also helps with the stress tolerance, especially because it can help with redox balance. Like there are a lot of redox and oxidative stress inside of the plant. And when you have a good balance in there, that keeps the plant in check. It doesn't allow for a lot of oxidative stress to happen in a plant, so the plant doesn't start having stresses. So by having some of those products applied, it can help the plant overcome certain stressful conditions. Now, the fulvic acids, as I mentioned to you, they are the ones that are smaller, have a small molecular weight, so they're smaller molecules, and they can actually penetrate inside of the root, the root zones and also the leaf. So they are most effective when they're applied foliarly because of this ability of the molecule to go into the leaves. Now, the humic acids, they do not do that. They are too large for plants to actually absorb it through the leaf surface. So they do not get applied on a leaf. They usually apply to the soil. Whereas the fulvic acids, they can be applied to soil, but they work best when they are foliarly applied. And one of the main idea with the fulvic acids is that they can carry nutrients with them through the membrane. So they would be a good, if you're having like nutrient deficiency, they would be a good carrier when you're using a foliar application because they could enhance the absorption of whatever nutrient you're applying to try to overcome the nutrient deficiency during the growing season. They also have a direct impact on physiological growth of the plant. They can mimic some plant hormones, which would make the plant respond better to stresses that are happening, but also just in general, respond better to the environmental conditions. It can increase photosynthesis, it can help increase chlorophyll content, and then in the association with all those improved mechanisms, it will also improve the energy efficiency of the plants. They are soluble in a wide range of pH, so there's no issues when you're using this in a tank application because sometimes they require some products, so you have to have only an acidic solution or more alkaline solution for them to not flocculate, whereas the fulvic acid, they are soluble in a range of pH, so they don't flocculate in solutions. So there's no concerns about them clogging your irrigation nozzles or things like that. And again, they are very effective in stress mitigation, primarily by helping with this redox homeostasis. For example, during oxidative stress, there's the formation of this reactive oxygen species that causes a lot of stress inside of the plant. And then by having some of these products applied, it can help in the elimination of this reactive oxygen species and then helps the plant stay in balance and not be stressed, depending on what's happening. The amino acids, they're basically just the foundation, the building blocks for proteins. And the way they're produced is the industry will take a larger protein of animal or plant bases, and then they will break it down into smaller units that is called peptide. And then those are further broken down into the free amino acids. Now, the amino acid is called amino acid because it has an amine group in here in all of the amino acids. And also some amino acids also have a sulfur in there. So it could become a little bit of a source for both nutrients. However, when we apply amino acids to plant, they're not really getting it for the nitrogen. They're actually using that amino acid as a source, as a building block for protein synthesis or enzyme activation or some other hormone that is being produced. So they actually use those molecules directly instead of having to remove ammonium and nitrate from the soil. Because what they do is when they remove ammonium and nitrate, they will convert that to amino acids and then use those amino acids to produce all those secondary components that the plant builds up. It can be very useful in stress defense. For example, when the plant is stressed, maybe there's a drought happening. One of the ways that the plant can cope with is by closing stomata and minimize water evapotranspiration. So some of those products can actually facilitate their closure. Whenever it senses that it's becoming stressful in terms of water content, it senses a little bit of osmotic deficit, then it will help close that stomata faster and therefore slow down the loss of water through them. And those amino acids, they seem to have a better response when they're combined with things like fulvic acid, primarily because of absorption, because amino acids, if I skip, but amino acids only about 40% of what you apply, 20 to 40% is the amount that the plant can absorb naturally. So when you combine with things like fulvic acid, maybe you're helping the plant absorb a little more, but it also helps them work a little better once they're inside of the plant. So just to quickly summarize those mechanisms, so these products, they are not replacing fertilizer. They're actually helping the plant become a little more efficient by enhancing root exploration, nutrient availability in case of chelation in the soil. They help with enzyme activation. They increase for example, they can increase sugar content inside of the plant as well. That could have another stress condition that could help in case of insect damage. Maybe by having higher sugar content can help the plant cope better with insect damage. And also it's really related to that oxidation and redox reaction going inside of the cells. So it's really helping with more of the abiotic stress inside of the plants and helping the plant to become a little more efficient with energy use. So they're not really necessarily going to make your yield much higher. If there is a stress condition, it can help cope with the stress. And then if that stress was going to reduce yield, maybe you won't get the yield reduction. But now if the condition is not very stressful and then you apply those substances, then they're just gonna, it's like washing the plant, right? They're not gonna do what they're supposed to do because the stress is not there. So there's not gonna be any yield benefit from using them. What I have seen from work that we've done is that they will work best when there is stress. Just like I said, if there's no stress, it's going to be hard for you to see a response. And then throughout the talk, I have in blue and underlined a few of those statements, because then later on, you're going to put it all together to try to give an idea of what's really going on with those products. But when they work, humic acids are going to excel when they're soil applied in very low organic matter conditions. And the longer you apply, they have this build-up effect that soil with low organic matter condition, the more organic matter you put it on, the more it's accumulating, and therefore the effects are going to be better as times go by and the more you use them. And then the fulvic and the amino acids, they work better when they're leaf applied, and they will have some impact on the metabolic activity of the plant, supporting energy production and efficiency. Now let's talk about the biostimulants, which are the bacteria, the fungi, the archaea, and some of those other products that are currently being used to help plant cope with stress. There are many different products out there that will help with many different things. There are phosphorus solubilization. Those microorganisms, they usually will help solubilize phosphorus from the soil by generating like organic acids that will help dissolve some of the organic phosphorus or inorganic phosphorus that are tied up into the clay minerals or soil particles. So therefore, they will become more available. There's also the nitrogen fixation aspect of some of those microorganisms. That is usually one of that's the most talked about right now, is the nitrogen fixing bacteria that can either be rhizosphere free living bacteria, or it can be an endophytic bacteria that you spray to the growing plant, and then the bacteria penetrates the leaf of the plant and then produces the nitrogen inside of the plant as well. There's some improvement in micronutrient absorption by creating, when you apply some of those microorganisms in the soil, they can create chelating agents that will help chelate micronutrients and help improve uptake by the plant. And then there's also the mycorrhiza that we already know that can help with nitrogen, phosphorus uptake, with water absorption. It has a wide range of beneficial use. They can also be important in phytohormone production and regulation. They can directly interfere with the hormone production of the plant, and that can be beneficial or it can be detrimental, because some of the studies we're seeing that if you're using this bacteria, for example, in black beans, we saw big negative responses by using some of those bacteria, because we believe it started interfering with the hormone balance of the plant, and that caused very big yield reductions. But in other cases, when the plant is going through stresses, being able to have those hormones being produced and can help the plant cope with the stressful condition. For example, if there's drought or if there is heat stress, then having some of those microorganisms be able to produce or activate those hormone productions, and that could help the plant cope much faster with those stressful conditions. Yeah, and also with pathogen and other insects damage, having the bacteria in there, for example, if you have a series of pathogenic bacteria that are going to come into the soil, maybe the bacteria that is there to provide some defense. For example, here you have a wealth of pathogenic bacteria. Then here's some of the bacteria that are good, the one that you use to inoculate your seeds. Maybe they're producing some compounds that is in response to the attack by the pathogenic bacteria, and then the plant will sense those compounds, and that will kick in defense mechanisms before it even starts being attacked by the pathogenic microorganisms. So it can help the plant get a head start in the defense against those diseases, and that would help the plant not suffer as much. And that's how we can see some improvement in yield. It also helps a lot with the osmotic potential of the plant, helping the plant cope with the water deficit, just like those amino acids were doing. We know that because of the way that it can interfere with the hormone production, it can also improve root growth and root exploration of the soil, and help with the overall structure of the root in the zone, in the soil rhizosphere zone, which would help with nitrogen and water absorption throughout the growing season. Now, for the overall mechanisms, so microbial biostimulants, they will prime the plant, is a nice way to say it. They are actually going to colonize the root zones. They will be producing beneficial compounds that is going to help the plant understand what's happening in the soil rhizosphere before stressful conditions start to happen. And again, they will trigger some of the pathways for hormone production that again will help the plant cope with the stressful condition. And again, here our blue line, the effects are strongest under stress. So if it's a nutrient poor condition, if the soil doesn't have a lot of fertility, for example, if you're renting a field, they have very low phosphorus levels, very low potassium levels, low organic matter, those would be fields that would benefit from some of those products. We see that when you're using different microorganisms together, we see this synergistic effect when you're using more than one type of bacteria. And again, they go well with the idea of sustainable agriculture and relying less on chemical fertilizers, but this will only work when the plant is stressed. For example, if the plant is growing under a condition where it's low fertility, there's not a lot of those good bacteria, and then we see here, for example, if we say that this would be a plant growth promoting bacteria, there's only 3 or so of those bacteria in the soil. They're not going to be producing enough nutrient for that plant to be able to make any benefit from it. But then let's say that we use this bacteria, we culture, and then we make a commercial product, and then we start using this product to inoculate the plants. Now you can see there's a lot more of those bacteria in the soil, and therefore the production of those, for example, here would be nitrogen. The production of nitrogen is much higher, and therefore the plant would actually start benefiting from having the nitrogen being produced by the bacteria. However, if your soil has very high organic matter, you already put down the crop needs for nitrogen, and you're putting down the bacteria as well, the bacteria is just not going to do anything because you already supplied the plant with all that it needs, and there's no stress. So if there's no stress, there's no response to those inoculations. Right, so it goes there. So say, but Paulo, why I don't see results? I'm using them. I like to make this analogy. You know, if you go to the bar and then you drink more than you should have tonight to celebrate being here, and then tomorrow morning you're going to have a big headache. So what do? Maybe you take a few Advil pills before you go to bed, wake up, you feel fresh. You can go to your next session of presentations. But now if you drink and then you don't take the pill, you feel the pain. But now let's say you went out, but you didn't drink. You drank soda, a can of soda, went home. But then before you go to bed, you also took the Advil. But had you not taken the Advil, you would not be feeling any pain. You would not be sore because you didn't drink too much. But you took the Advil. So did the Advil work or not work? Well, you didn't have pain. So why would the Advil work, right? You took it, it was there. It would have worked if the condition was there for it to work, but it didn't work. Would you do that if you knew, right? Would you take it if you knew you wouldn't have pain? Perhaps not. So what are the best ways to use these products? For humic substances, when you do want to use them, they are usually applied to the soil or the leaf if you're using the fulvic acid. The humic acid, again, as I mentioned, the more you use, the more repeated applications you do, the better it's going to be to build up in the soil. But you usually do one application a year, and then you do that again the following year, and you keep doing it until they start to work. But there, I would say that instead of using humic acids to help increase soil organic matter, there are many other practices that will do much better job at increasing soil organic matter than humic substances will. Now, if you're using as a foliar applicant, using your fulvic acid, then usually what the research shows is about every 4 weeks application. If you're seeing a stressful condition kicking in, maybe apply every 2 weeks. That could be useful. But again, those products are expensive, and depending on what stress you're going to encounter, they might not really be what you're looking for. Maybe other agricultural practices might be the way to go again to try to help the plant cope better with those stresses. And again, it's best to use fulvic acids more frequently at lower doses than put a big dose and wait a long time to apply them again. For the seaweed, there are 2 products on the market. There's the solid seaweed extracts. They are a powder that you would have to apply them to the soil and then incorporate them in and then wait for those products to start breaking down before they start working. And then the extract, they're best used as a foliar application. So they can be applied once the plants start growing, depending on what you're using them, anywhere from when the plants start flowering to when it start silking, they would be the best way. Well, silking, you might not be able to apply them anymore, but for soybeans, when they start flowering, it would probably be the best time to start using them, depending on what you're looking for with those products. Again, they are not a source of fertility or nutrients. They're going to help you cope with stresses, right? If you think that maybe the plant is deficient in a micronutrient, you're going to put the micronutrient down. Maybe having some of these products with it would help improve the efficiency of those micronutrients. But just using them because you think it's going to help the yield, that's usually not going to pay back. The amino acids very similar. Again, the amount that the plant is going to absorb is only about 45% at max. And we see that there is a little bit of a better response when you're combining amino acids with the fulvic acid because there's a better absorption of them. And again, the best way to find the rate is by doing what's recommended and maybe start playing a little bit with what you're doing at your own farm. I had a couple folks talk to me a couple weeks ago in Lamberton saying that they are experimenting with fulvic acid and amino acids to help with aphid in soybeans because it can really improve the Brix content in the beans. And then that was showing to minimize the aphid attack on the beans. So they're seeing some positive response there. And depending on what crop you're using, you can also do, like for vegetable producers, those products can really be beneficial when the fruit's starting to grow. That could help increase, for example, in sugar content or other antioxidant production inside of the plant. What crops should they be used on? Again, they can be used on any crop, but the main thing is they have to be under stress for you to see any response to those fertilizers, biostimulants. And one thing to keep in mind is how much the value of the crop is going to increase based on how much you're putting down. If you're spending $50 an acre with products and the increase in yield you're getting is only $20, would that really be worth it, right? You're just putting more money and not really getting that money back. And again, the main thing is, I keep hitting this, how often does your farm experience the stressful conditions that those products are going to help you cope with? If the answer is rarely, then you should be using those products rarely or perhaps never. But if you're constantly under stressful conditions, then it's time to start playing with it and see if they're going to be working for you. And again, the best way to know if they're going to work for you or not is by testing on your farm. You know, that's the only way you can tell whether or not they're going to work for you is by playing with it. I wouldn't go the full field, maybe do a pass or two and then have some comparison strips on the side that you can look at it and see if it's working. There are some of the products out in the market that they say, oh, you can reduce 20, 30 pounds of nitrogen when you use this product, and then you can do a strip. Do the strip the full rate and do the strip with the reduced rate plus the product. And then they will see if that was effective. But then that really doesn't show you whether or not the product worked. It only tells you whether or not you lost the yield for the fertilizer that you reduced. So you should do 3 treatments, one with the full nitrogen rate, one with the rate reduced without the product, and one with the rate reduced plus the product. And that will tell you for sure whether or not the product is working. Because it could be that just by reducing a little bit of nitrogen, you're already over fertilizing, and then you reduce some, you still had enough that the plant didn't really feel that deficit. Again, so here we go. As I had highlighted, right? So effects are strong when under stress. If the plant has a stress, immobile nutrients in deficient soils, again, you have to have stress. If you have no stress, it's not going to work. You're just buying a product that is doing nothing for you. Especially in Minnesota, our soils are so rich in organic matter, have so high fertility, and many of you are already doing a lot of this sustainable agricultural practices. I don't see where this would be very useful when you have already been doing so much to improve the conditions. What we're seeing is the next talk next week in St. Cloud will be this talk, but again, just talking about research results. What we are seeing is when we have an area that is very low, very sandy, gravel ground, we start using some of these bacteria, we start seeing very positive responses. And then if you have a field that is across the road that is very high organic matter, well drained, there's hardly anything that works in those grounds. Now, one thing I want you to be aware when you're talking to industry folks, there's one thing that they do quite often. They will do the trials and then they come and they show you a graph, a bar graph like this. They say, well, here you have the control, and then here you had your treatment, the product we tested, and there was about a 15 to 20 bushel increase there. But they don't show you the statistics. They just see the raw result, and they're saying it was beneficial. It was numerically beneficial, so it was a trend. Well, that's because in 2025, there was a result. If you do the same trial, the following year, it might happen to be this way. You do it again the next year, they are all exact the same number. So the reason here this is happening is when you have an average, that means there is a large number of values that go for you to get the average. There will be numbers that are above the average and numbers that are below the average. And this is what's happening here. You just, by chance, this treatment had the lower number now, which would be over here. And then this treatment had the higher number, which would be over here. But when you put it all together, this is all part of the same family, right? Statistically, they're all the same. It just by chance, this happened this year. But again, by chance, another year, this could have happened. So you're not going to see a salesperson come to you and say, well, in 1 year, you might get 200 bushel improve in yield, but the other year you might have a 200 bushel deficit in yield, because that wouldn't sell, right? You're not going to buy a product that will cause you a deficit in yield. So the way it works is when there's a statistical difference, then there are these two populations. One here, you have a range of numbers that would be for one population and a range of numbers that would be for the other population. So you have to take this all under account to then start saying who is better and who is lower. So some things that when you're talking to industry and you're being sold the product, things that you can ask for is what is the least significance difference? What's the LSD? Because, for example, if the LCD was 25 bushels an acre and here only seeing a 15 bushel an acre increase, that means they're statistically the same, right? But now if the LCD was 10 and you see an increase of 20, then yes, then you got a big benefit from using that product. Another trick, you know, the LCD, there's a trick with the LCD, and you see a lot with the industry. We at the university, we do our research trials with all 4 applications because we try to do our best job at locating a field that is going to be somewhat homogeneous. There's not a lot of field variability. So doing a trial with 4 reps, it's good enough and you can get good data from. What industry likes to do is do 6 to 8 reps. So what that does, that minimizes the LSD. It makes them smaller. So the smaller the LSD, the easier it is for them to show that there's something that is actually different, when in fact, it wasn't really different. And the other thing that I get a little bit concerned about those products when there's too many rates is because of inconsistency. That's something that we see a lot with those products, is that they're not very consistent. Maybe one plot will show the result and then the other 3 don't really show any result. And then by having more reps, it just showed that the product is less consistent. So they try to have more reps to get data that somewhat would be useful later. So two things for you guys to ask for. What is the LSD and what was the number of reps used in that treatment trial? So if it's more than 4, I would be a little concerned. Is it because the product is not consistent, or is it because they are trying to make the LSD smaller to try to show a difference when it wasn't really there? And again, just ask, what are these results you're showing me? Is this statistically different or not? Because a lot of times, like I showed you here, they will show you a graph like this and say it was a benefit, but really it's not statistically, but numerically, they are very different. And that's it at the 5-minute mark. So we'll open up for questions. We went too far? Oh. Can I just go? Okay. So any benefits to adding biologicals to compost? I don't think so, because the compost is actually producing your biologicals. So because the compost is going to have a broken down of all those hard to break, the easily broken compounds already broken down by the microbial community. And there's also going to be a microbial community in that compost, assuming that was done properly. So it's all going to be beneficial microorganisms in there. And then the fulvic, humic acid is all going to be produced as well. So there's really not much benefits from adding any biologicals to compost. Now, if your soil is very low in organic matter and fertility and you're using the compost, then perhaps you could use some of those biologicals to supplement as the plant is growing, but not really to the compost. I would not see any addition. Would it be safe to say these products may help more on soils that have a history of heavy tillage, pesticide use, versus soils that have been farmed for years with soil health principles, fully functioning soil biology? So yes and no. If you're so even with heavy tillage and heavy chemical inputs, if your soil is high in organic matter, it's a well-drained soil. Our Minnesota soils, because they're so rich, they're very forgiving. You can do they take a lot of beating, and then within a season or two, they recover very quickly. I would say if you look more at the fertility, what's the fertility of your soil and what's likely the particle density? Like, are you seeing water stress? Are the plants looking that they're suffering from drought in mid-July to early August? If they are, then those would be the fields that would potentially benefit the most. Nor really the history in terms of tillage and what you did with the soil. What is the benefit of these products in coarse texture soils, less on organic matter that are under center pivot irrigation? So yeah, these are cases where we would expect to see good results from these products. For example, the humic substances will help a little bit with more providing more carbon to that soil. If the microorganisms in there are starving, they would have an extra source of carbon for them to work on. There would be higher charge sites for nutrients to be held in those soils. And again, this would be something you might not see on the first year after applying some of those products. You might have to apply them for 4 or 5 years before you start seeing any real benefits from them. But those are the conditions where we would see the most results: low organic matter, high sand content, water stress. Right? The water, it will be a stress. Like, we are doing a trial in Becker that Carl is helping us with. In the first 2 years, we had full irrigation. We didn't really see much response there. And then if we get the funding this year, that the corn growers are funding the trials. If we get the funding this year, we talked about doing some irrigation deficit to look at water stress and see if then we start getting more of those responses. But the soil organic matter there is very high. So we might have to do a little more digging to see if we find a location that has a lower organic matter, do the water deficit, and then see how well those products will work. Do you ever come to any conclusions about green lightning? So for everybody knows what green lightning is. So there's this company that they came up with a liquid plasma machine that you pass water through the liquid plasma, and that's like a lightning bolt inside of the machine. It just breaks down nitrogen from the air, it makes into nitric acid, and therefore you have like a nitrating solution. Now, they say that you have about 2 to 3 pounds per gallon of nitrogen in that solution after that's done. And that's impossible. That would be 20% acid solution. And a 20% nitrating in water, that's a very strong acid solution. So all the tests that we done, we get about 20 ppm of nitrogen in the water, which is like 1,000th of what they say it is in the water. And they say you got to apply 70 gallons per acre. And we figured out you got to apply about 27,000 gallons per acre to get any significant amount of nitrogen. However, we did have a farmer last year that did the trial too. He got water from somebody that was selling the water from the machine. And he had somebody do a trial for him, some person that does trials for farmers. And they saw some good results. And we did too, and we never got anything. Our green lightning plots always match the control plot that has 0 N. It's usually about 90 to 120 bushels an acre without any N or with the green lightning. So short answer is it's not working.
Cut it off here, Paulo.
All right, thank you, everybody.
Okay, thank you. So